Welcome everybody to today's session. We'll just wait a few more minutes so everybody can join. So I see a lot of people joining. That is great. We'll wait a few more minutes so we have everybody settled in. Just make sure that everybody has a good connection. So we're just waiting for everybody to be able to joining. So wait a few minutes and then when everybody is joined, we will connect. So I think, as I can see no new people joining in, this is going to be our session of today with the amount of people. So welcome everybody to today's session. Um, it's a session about LODs, and we'll also take a little bit of a side trip to what's called nested LODs. What are they? When can you use them? And how can you use them? It would be great if you want to. I've seen a few more people joining in. Welcome everybody. And so we're going to talk about LODs and how you can use them in the workplace. You're more than welcome. Actually, I implore you to build along with me. So what I'm doing at the moment myself, I'll be using the sample superstore. If you do not have the sample superstore available to you, you should have it in your Tableau because that's the basic data set that Tableau always provides with their desktop application. If you do not have that access, I just posted something in a link in chat where the community is giving that sample superstore. I'll just give you a little bit of a moment to click on it and download it and connect to that data if you want to build along. I'll show you a few examples, like I said before, and I'll also allow you some time to start building. If you are using this sample superstore, you're using your own version of sample superstore, be wary that if you're using a little bit of an older version of Tableau, you might have a slightly different data, so it might not look exactly the same, but as long as you're getting that same core principle of what we're building, that's absolutely perfect. I just want to let you know we are recording this session because we will be posting this webinar onto our YouTube channel, and I will also provide you a link to that YouTube channel all the way at the end. So just so you know that if you are giving a chat or a Q&A, and I might read that out, it might be on YouTube. So like I said, I mentioned the Q&A very shortly. If you have a question, you can use the Q&A section to sorry, Emma just notified me that I was only chatting to her. Emma is my colleague, and she's just helping you with that link. If you have a question, ask it in the Q&A, or you can ask it in the chat. I will do my best to keep my eye out for that Q&A and the chat to answer your questions. If you have any questions during the session, oh, give my mic more power. Let me see if I can do that, Matthijs. And otherwise, I'll need to shift some of my sessions. Let me see if I can do that. Oh, and now I messed that up. I should be sharing my screen again, and I should have a little bit more control. Let me see if I can get that under control. If it's still too soft, let me see if we can fix that. Emma can hear me fine. Okay, but if you can just up your volume maybe a little bit more. Oh, it is okay now. Perfect. That's good. Thank you all for letting me know. And these are the type of things that you can let me know as well. Just speak up or talk a little bit softer. That's also a very valid question. Like I said, it will be on YouTube. We'll also be sharing that YouTube link at the end, so you can also find this recording of this session. So what we're talking about are LODs and nested LODs. And I'll first give a little bit of an insight on why we're talking about these type of calculations and what they are and how we can use them. To start us off with, this is a picture created by Tableau to talk about stuff what's called aggregation and granularity. When we are building in Tableau, often what we are doing is we are aggregating our results. And aggregation can be a sum or looking at the min of a certain value. And I'll show you a little bit of an example later on exactly what we mean with aggregation. But as you can already see, we have less aggregation, which means that we're working at the, for instance, the row level detail. Oh, the screen is paused. No, my screen shouldn't be paused. Can you see me clicking? And do you see a little bit of a circle beeping? Let me see. Zoom share. It's blank. I'll try and reshare. Are you seeing the screen now? You should be seeing a, you just see, okay, I'll stop sharing. A little bit of technical difficulties apparently. I'll share my screen again. Can you see a little bit more now? Just try rejoining. What I'll also try, and if I can share my other screen. I have two screens, so let me see if I can share my main screen. Oh, you can see it below. Oh, perfect. Perfect. I can just see that everybody can see what I'm looking at again. So what we were talking about aggregation, the level of aggregating, or how we are aggregating and what type of value we can expect. And we see the pointer too. Ah, that is perfect. We can have more aggregation, which would be the complete data set, for instance. That's the highest level that we can aggregate something at, which for instance would give us the sum of everything. Or less aggregation, which means we're sometimes even not aggregating. That is at an even lower level of detail. So we're not aggregating anything at the row level. I will go to a little bit more detail and it will make a little bit more sense maybe. So that's called aggregating. We're summing, we're averaging, and we have a term called granularity. And granularity is basically less granularity means we have less detailed information. If we're looking at that same picture where we have the total aggregated, so the whole of our data set, that is not very granular. We only have one number. If we're looking at the state level, when we have our data, we are aggregating at a lower level because we're aggregating at the state level. So for instance, sales per state. And our granularity is increasing because we now have data at an even lower level than the total. And we can keep going on and on to county level, maybe city level, or in the end, our um, lowest level, which is our row level data. Now, to give this a little bit more context, how does aggregation work in Tableau? And I'm going to show you two examples on how this works. And feel free to recreate this example. At the moment, I'm having my superstore on the left-hand side. Um, and we have on our row shelves, we have both region and state. So we can say that we are at the granularity level of state. And at the moment on the left hand side on my marks card, you can see average of sales. So I'm aggregating sales at the level of state. And as you can see, I do not have my information on region level because Tableau is aggregating at the level of state. And every time I'm building in Tableau, my rows and my column shelves together with my marks cards is determining at what level I am aggregating. And you can also see that even further when we dig deeper onto our state level. So I'm digging deeper, having that little plus symbol that you might recognize when you're building in Tableau, creating that hierarchy that allows a drill down. If we're drilling down on city level, we're automatically telling Tableau to aggregate, which is that average of sales. And now we're aggregating at the city level. So Tableau is automatically aggregating. And we're determining the granularity using those columns and row shelves and our marks cards. Now, an even better example perhaps is when we're looking at a scatter plot. You may have built this in the past yourself as well, where we have two measures, one on columns and one on rows. So in this case, we're looking at profit and we're setting it off to sales. If we're making more profit, hi, yep, the data set for this example, it is either the superstore, which you would have available to you in any desktop Tableau installation, or you can download in this link where someone has uploaded an Excel version of that sample superstore. You might get a slightly different results, like I said at the beginning of this session. Um, that has to do with if you're using a 2019 version of Tableau, you only have data up to 2019, and Tableau is now having 2017 to 2020 data in there because they're just updating that year. But you should get very, very similar results. Now, getting back to that granularity and the aggregation, Tableau is doing, in this case, both a sum of profit and a sum of sales. And we're not aggregating it at any level of granularity. We are, as you can see, there's nothing blue, so to see. There's nothing on our column and row shelf or on our marks cards that's telling Tableau to aggregate at any other level than the whole of the data set. So if we're going back to that granularity picture, our level of aggregation is the highest level of aggregation, and it's the lowest level of granularity. The great thing about Tableau is we can start adding more information, such as region to detail. And as you can see, suddenly we have 4 dots instead of 1. So we're adding granularity to it, and we're lowering at what level we are aggregating. Now, why is Tableau aggregating? Well, one thing is I'm telling Tableau to aggregate this using that sum profit. And we can actually go to our analysis menu at the top. And there's this little check mark. It says aggregate measures. I could unmark this and Tableau would automatically not aggregate any of the measures. As you can see, there's that column and row shelf where it now doesn't say sum profit, but it just says profit. And no matter what I have, I can even remove this blue region from my detail level. And I only have dots, but I have dots for every row of data available to me. We're looking at that data. Just look at view data on the left side corner. We're getting data for every one of these rows. We're getting a point in my data set. I can even check that by looking at the top left corner where it says 9,949 rows, and all the way at the bottom where it says the amount of marks available in this visualization. That's also 990, 9,994. Apologies. So that's the exact same amount. So by clicking on analysis and saying, I do not want you to aggregate measures, I can go to the very, very lowest part. That's the highest level of granularity and the lowest way of aggregating because I'm not aggregating. So I could add indeed region again to details, giving me those 4 dots, or I can drill deeper, and now I can see something for every state. The great thing is, so Tableau is automatically understanding at what level of granularity I want to aggregate. The downside would be if I want to do aggregation on 2 levels of granularity. And that's actually what we can do with that level of detail. We can force Tableau to do the aggregation at a certain level of granularity. Now, I'll first show you the syntax. How do I write these type of things in Tableau? And then I'll show you a few examples and you can build them with me. Now, the syntax of these types of calculations, and these are the only ones that will use that curly bracket. So normally when we are doing calculations, we might use brackets, but these will be the only time in Tableau that you will use these curly brackets in a calculation. You will use a keyword. There are 3. One is called fixed, the other is include, and there's exclude. With fixed, I am setting that level of granularity at that exact level that I want it to be. At an include, I'm actually saying you need to, aside from what is in your visualization, at least include this level of granularity. And with an exclude, I'm saying whatever is in my level of granularity is in my visualization, I want you to exclude this level. So if you can look at these examples on the right-hand side where we have state, one is saying I want you at the level of state, calculate the sum of sales, no matter what is in my visualization. When we say include city, even though my visualization is at the level of state, I want you to calculate whatever I'm doing at the end, that aggregation, at the level of city. And the other one would be, even if city is part of my visualization as a level of granularity, I want you to not take city into account. So that's how those different keywords work. And be aware, it's great. You can have multiple columns set there. So when you're forcing that level of granularity, it doesn't have to be just state. You can say state, comma, city. So then both state and city within state will be taken into account, as that's the level of granularity for this calculation. So you don't have to do one level there. You can have multiples. You can have up to n amount of levels of detail that you're setting there. What is a good example of setting that level of detail in a calculation? Well, one of those things are used for, and I'll show you, is to do a cohort analysis. This is a very good example and a basic example that is used in trainings to explain level of detail calculations. What we're looking at here is the first year a consumer has purchased from that superstore. So in this case, if we're saying we're running that superstore, this is the first year a customer has bought from us. And we're calculating for every year that we're selling things. When was the first time a customer bought something and when are they repurchasing something? So that's how I should read this example, this visualization. You can see on the right-hand side, those are my colors, and I will show you exactly how this calculation works. But first I want to explain what are we reading. On the right-hand side, I can see for every consumer, when was the first time they purchased. So blue represents 2017, orange 2018, etc. Now, in 2017, for every region, 100% of my sales comes from people who bought for the first time in 2017. That means, well, that's kind of obvious because that was the first time we were having that data. But in 2018, I can see that 76% of the customers who bought something, or from the orders that I did, were from customers who bought something in 2017. That is how I should read this. And I can see that in 2019, 77% of my sales are from customers who bought something in 2017. This does not mean those percentage of sales that these sales are from people who bought something in 17 and 18. All I know is they bought something in 2017. Now, how do I build something like this? Well, we first need to know when was the first year that someone purchased a product. And I will go to my folder and I have a calculation ready where it says first year of purchase. I will edit this and I will show you exactly what this looks like if my editor will allow me to go to this screen exactly like so. And I'll make it a little bit bigger. I hope you can read this. What we're seeing right now is indeed those curly brackets as expected. And we see that I'm using a fixed level of detail. That means I'm telling Tableau whatever is in my visualization. Customer name is the level of granularity that I'm doing my aggregation at. So you can type in, if you're ready and to follow along with me, you can start typing in that curly bracket and then fixed customer name. That's the very first thing, and I'll give a little bit of an enter so you know exactly what it would look like. So I'm telling Tableau customer name is my level of granularity. And because we're working with a level of detail calculation, I will still need to tell Tableau what type of calculation are we doing at that level of customer name. Well, in this case, we'll need to type in I always forget the name, it's a column, because after the column, I'm telling Tableau what type of aggregation are we doing. Well, I want to know the minimum value of order date, because I want to know when was the first time someone purchased something as a customer. Now, in this case, we'll do a min, because that is an aggregation. And then I'll throw in an extra year for order date, because that way I know this is the first year that someone is buying something from me. Who can tell me and already see what could be a downside of using, for instance, something like customer name as that fixed level? And feel free to use the chat to let me know what type of trouble I could run into by using customer name. It's not unique. Like Rick this is saying, it's not unique. Same customer, same name. I do not have, unfortunately, anything other than customer name. So like Rick and Chitral are saying, it's not unique. So I'd rather have a customer ID than having a customer name. But in this case, if I only have customer name, that's what I'll work with. But I'd rather have something more unique. So if you have that available in your data set, please definitely use that more unique value. Well, in this case, I have that fixed customer name and then the first time they ordered anything. I'll click on OK, and I have my first calculated field, and actually the only calculated field that I would need for a cohort analysis. And what I'll do now, I'll clean all of this up, and then we're going to start building it together once more. So in this case, we'll grab our region, because we wanted to know per region when was the first time people were ordering. And we'll go back to our order date. And in this case, we'll have those years that someone purchased something. I want to know the amount of sales. I don't like this line graph, so I'll change it with my marks cards to a bar, so we know the amount of sales. And then we need to split that up. This amount of sales, we need to tell Tableau I want to calculate at a different level. Well, I'll need to split that up. I'll do that on color. And then we see the first year of purchase. Now I like to throw in what percentage is that then. So I'll drag in sales on label. I'll right click that sales, do a quick table calculation as the percent of total, do another right click because I need to compute using not table across but table down, and then I know how much of my sales are from customers who bought something for the first time in 2017, 2018, or 2019. I'll click next to that little pin symbol to do the entire view, and then it looks a little bit nicer. I can clean this up a little bit more with a right click and going to Format. I'll go to those lines, and I personally often remove the grid lines because I don't need them. Now, this is a great analysis to know when were people buying for the very first time, and am I leaning a lot on older customers or returning customers? Because as you can see at the end of 2020, I have very, very few new customers, which could be a good thing or it could be a bad thing depending on what your business is. But if you would lose those older customers, then you will have trouble keeping your company alive for a very long time in the future. So this is one of those reasons why you could use a fixed calculation level of detail calculation to do this cohort analysis. There's another way that we can use level of detail calculations, and that is to compare on different levels the sales. In this case, what I wanted to do, I wanted to know on a state level the average sales, but I wanted to compare it to the average sales of a region. So I know these states there are set up per region. My visualization, but I'm just looking at the average sales, will always be at the level of that granularity that is in my visualization. In this case, state. Now, what we would need to do is we need to somehow also tell Tableau to tell me the difference, the average of sales for a region. Now, how do we do that? There's a few ways. We could indeed use that fixed level of detail again, or let me just clean up these folders a little bit. We can also say, I want to know the sales for a region, or the average sales for a region. And I will make this a little bit bigger. And in this case, if I know that my visualization will only be at the region and the state level, instead of fixing it on region, I can also type exclude state. So you can type along with me again, and I will make this a little bit easier. Use again that curly bracket, and we're excluding state. So independent of whether state is in my visualization, I will not take that into account. So because I'm not taking state into account, at what level will Tableau average the sales? And you can use chat if you know the answer. Region. So Bart Brouwer is saying you will use region. Perfect. So I'm looking at the average sales on region level. So I'll show you a little bit how that looks like. I'll just drag that in to my measure values. And as you can see, it will also show the same value for every state, which is normal because every region will have that same average. Now, if I go up one level, you can see that my average sales is actually the same as my sales per region. And that makes sense. I'm saying to Tableau, do not take region into account. Perfect. But or do not take state into account. Perfect. But if state is no longer there, I also don't have to take it into account for my normal average of sales. So now both of my sales per region and my average sales, which is just the normal sales averaged, are both on the region level. But if I go one level deeper, I can see that I get that difference. So now we have our average sales, which is just sales from the left-hand side of my data pane, dragged in and put on average. We have that result of sales per region. And now what we could do is look at the average sales and minus that sales per region. The sales per region, the sales per region is a calculation, so I would need to say I would already need to tell Tableau to use average, because if I'm not averaging this, I can do this. I didn't know that. But I want to force Tableau to use average, because I know I want to use that difference between average of sales. And now you can see something which I think is always really cool. Using that fixed level of detail, or in this case an exclude, so a level of detail calculation, allows me to calculate once more. In this case, I will use 8TTR because I don't want to do a calculation because I already know what that will be, because it's only all the same for every state. I have that same value of the average per region. So when we're comparing that, we'll get that difference. So on the right-hand side, you see that difference. I have once more dragging that sales. So the difference between the average sales for Illinois and the difference between the average sales for Central is minus 52.83. Already showing me this is great value for to know on the state level if their average of sales is higher or lower than the region. I can even, if I show you once more, use logic with that exclude level of detail and say if the sales difference per region is bigger or equal to 0, then I either positive or negative, and I can color code my table. So using that to color code my table, as you can see on color, I actually see already per line immediately with the orange, these are locations that can maybe learn from the bluer locations. So I now know on 2 different levels what the average sales is. One is on the level of state, one is on the level of region, but my visualization is always on the level of state. Yeah, the color for perfect. So the calculation, I'll show you both calculations all again. One is indeed for the color. In this case, I'm using a kind of sneaky way of using a calculation in Tableau. I want to have 2 colors. I know something is either true or false. So there's 2 ways that you could do this. One would be this particular way. You can write an if, and then the sales difference per region is bigger or equal to 0, then true, else false. And that's a perfectly legitimate way of writing a if this is happening, then true, otherwise false. Using this sort of sneaky quick rule, sales difference region, which is that comparison between the average of sales minus the sales per region, the average sales per region, is that bigger or equal to 0? So that means if it is bigger, my average sales on the state level is doing better than the average states on region level. And this will give me the value true, and otherwise it will give me that value false. So this is sort of a quick way of writing a true, false, a Boolean statement. I can do what Mike is saying is a very valid point. I can also put the measure on color so that we get sales difference per region. I'll remove this sales difference per region on color. Go to edit color, stepped, use 2, and then apply. Both, to me, both are valid. So Mike, this is a very good question. So what Mike is doing, what they're doing is actually using that sales difference per region that we have on the left-hand side, where we also have as a number, and we drag it onto color, go to color, edit, and make it step 2, or in advanced, you're absolutely right, I have to set my center to 0 and apply and make sure that my center is 0, but we're making 2 steps of color, and I know already what my end color will be and my other end of color will be. So I have 2 color options. I need to set my center to 0, so around 0 it will go from either one side or the other side, and I click on OK. In my opinion, there's no big difference other than the fact that we're using a very long range to do colors instead of having those 2 values. The Boolean gives me just 2 options, and I personally prefer that one. It gives me a little bit more freedom of setting the color and playing with that color in a legend, because I couldn't show this as a true false legend to my end users. But if I use true false on color, I have a very nice true false statement on the right hand side. I want to show you one more example just to give you a little bit more insight on that include, exclude. And if we have more time, I'll also show you some nested LODs, but I also want to take time for a Q&A at the end. So we'll first move a little bit further along the difference between that fixed include and exclude to really drive that home. To do that, what I've built is this. It looks very boring, in my opinion. What we have a table just based on that region at the moment, and I'm showing the average sales. I've set a fixed level of detail, and I'll show you. It's fixed on state, and on state, I want to know the average sales. So it's fixed with that curly bracket, state, then a colon, because I have to tell Tableau what type of aggregation am I doing. So I'm always giving that level on the left-hand side, and on the right-hand side of the column telling what are we aggregating, because we always have to aggregate something. In this case, it's the average sales on the state level. I have an exclude, which actually is a copy of that very same format we just created. But instead of fixed, we have exclude. So whatever we're doing, we're not taking into account state. And we're doing the average sales. Then we have include. I'm saying include state. So again, we're having that terminology. Or do we do fixed, include, or exclude? At what level? What level of aggregation must we take into account, or are we setting Tableau to take into account? Do we need to take into account, or do we not take into account? In this case, I'm saying definitely include state. And we have an average of sales again. Now, on the left-hand side, you can see that measure values. As we can see here, we have sales, just average sales. Then we have that fixed level at the state level, that fixed. Then we have exclude, where we say we don't take into account state. And we have include, where I say definitely take into account state. Now we have a few options. I'll see if I can drag this a little bit bigger so you can see it bigger. I'll set the text to a little bit of a, let's see, I hope you can all read this. I hope this is more legible. And as you can see, the average of sales on the region level is exactly the same as where I'm excluding state, which is no surprise because state is not a level of detail which is in my visualization. So I don't need to take, I don't have to exclude it because it's not there. So both of the average sales are the same. My fixed level of detail is on the state level, which is different because what I'm first doing, I'm first calculating the average per state, and then I'm doing another average. So I'm actually averaging the averages per state, which is completely different than doing an average on the region level. And my include is the same as that fixed level. I'm at the moment, I'm at a higher level than state. I'm telling Tableau, you definitely need to also take into account state. And at my fixed, I'm telling Tableau, whatever you do, it needs to be at state level. So these two are now giving me similar results. I hope so far that makes sense. Now what we're going to do is we're going to drill down that region level to a lower level. So we're going to drill down to state, and we can see how our different calculations are going to show us different results. Now we're drilling down on that state level. So this is my normal way of Tableau calculating the average of sales, and Tableau is taking into account the level of detail that is in my visualization, and at the moment my lowest level is state, so I'm getting the average of state. Very normal. This is what I would expect. Now we have our average for fixed, which is the same as our normal average of state of sales, which is both at the state level. My first calculation is looking what blue fields are on column rows and on my marked cards. Well, state is the lowest level. My exclude, however, is not taking into account state. Therefore, it's 215.77, which is actually the average for region that we built previously. So again, showing you very briefly, going to region, we see central is indeed 215.77, and it keeps on being the same because we're excluding state from our calculation. Now our include is exactly the same as our fixed and our average sales because I'm telling Tableau include state, no matter what level we are on. So we have the exact same versions for all three of those. Now we're going to go one more level deeper beyond state. We're going to city level. And here again, it's very interesting. My normal calculation is taking into account the lowest level, which is city. My fixed is taking into account, well, everything but city in this case, but also not region, but state. So the same for every city and state. My exclude is saying I'm excluding state, but I am looking at city, and city at the moment is a lower level. But I'm not taking into account state. Now our other average, which has include, so include state, does include and has the same amount as our exclude. Now, something very interesting is happening at the moment, and I'm going to go into a little bit more detail. I'm going to look at the same thing with you together, because you may notice that exclude should be the same as our include, but it's not. We have 120.49. My include is also 120.49, but our exclude of state is 104.52. Who can already guess why excluding state at the city level is giving me a different result Then include state at the city level. This has a lot to do with geography. Perfect. So Hans and Bart are giving the same answer, and that's exactly it. You can have the city, in this case Bloomington, and what we'll do, we'll put that on a filter. So I'll filter to Bloomington. I will apply this filter. I have two versions. Both of them happen to be in the central region, but they are in different states. Well, in my exclude, I'm telling Tableau, don't take into account state. So that's why we're getting different results compared to our normal calculation of the average, and a different result than including state. So this is a great way of, indeed, if I use exclude, I need to make sure that if I go on a lower level, I either fix this or know what is going to happen there. So these, I just wanted to show you these very simple calculations, one next to the other. The workbook, I can see if it can be shared, but do know that there will be a YouTube video based on this sheet row, and you can follow along with that YouTube video and actually pause it on certain calculations that I'm using, just to give you a bit, indeed, more of a idea of what's happening. Perfect. I will also share a link to that YouTube at the end. For now, what I want to do, I will give you a few minutes for a Q&A session. If you have certain questions, I can answer them. If we have more time at the end, I can show another example. But let's first open up the floor for any questions you may have on those level of detail calculations or any of the exercises that we've just been doing. I'll So feel free to use the chat or the Q&A to ask a question. And if there are no questions, what I can do, I will show you one more example. Oh, what programming language? So Paula, what do you mean with the programming language in particular? Uh, ah, well, in this case, this is a very particular thing, which is to use the Tableau. So this is just for Tableau. So that fixed or exclude and include is something very particular to how Tableau works with data. So this is better to be used within Tableau. I don't know exactly what language or what is ideal. Um, well, in Tableau, you don't need any particular programming language. It is using what they themselves call VisQL. So if you know any SQL language, that is a very easy way of learning about Tableau. Bart, I'm going to get to your question, but I see someone has something asked in the Q&A as well, so I'll come back to your question. There is a great resource someone asked, and I'll look that up. Do you have an overview somewhere of really great use cases for LODs? Well, there is one, which is, I think, one of the best and most written white papers by anyone. It is top 15 LODs by Bethany Lyons. You may know her as well as someone who's just come up with her team to integrate the relationship model within Tableau. Very, very good examples. 15 ways of LOD expressions. Let me see, there's two more questions. Why would you use this, for example, in the dashboard filters? You could, but Bart, if you are looking, for instance, at comparing state sales to regional levels, you wouldn't be able to do this without level of detail calculations. Because if you are using that filter or that drill down, at the moment I'm looking at state level, I cannot calculate region sales unless I'm using that either exclude or fixed level of detail calculations. And if you are filtering, um, you can do, there's a little trick, which is great, is level of detail calculations, particularly the fixed level of details, is actually happening before you do any calculations. So just to give you an example, I'm going to create a calculated field. And Clemens, I will get back to your question as well. I just want to show this to Bart to answer his question. If I want to know, for instance, any order date, uh, the max order date, so the latest order date that ever existed, I could do a quick fixed, and there's another great trick. If I don't, oh, it should be fixed the formula. If I'm not giving Tableau any level of granularity in my uh, code, it means for the whole data set. So this is fixed for the whole data set, and it means that I'm doing it at the level of no granularity, and I'm grabbing the last order date. Now I can apply this. I can search for that max order date, and I'll put that on rows. And as you can see, there's 1 year. I'll actually make it an exact date, and I personally like that as a discrete. So you have this one value. And the cool thing is, if I now have order date, I go to my filters, I go to years. If I just look at 2017, what you might expect is I'll get 2017. Actually, I'm still getting the same max order date. So that fixed level of detail happens before I get a dimension filter. It has to do with the order of operations in Tableau. And I will give you a very good example of a picture, which I have always ready to go because this is one of my favorite pictures. That is one of my favorite pictures and explains exactly when things are happening in Tableau. Why not create a calculated field for state plus city? Concat the strings. Yes, that could indeed fix the issue of not taking into account state or city. Hans is saying, let me see, hypothetically, if a city state, that could definitely be that has to do with the order of operation. What Hans is saying, you can find a person aside from filtering maybe indeed on team lead, and you filter on the newest team lead, but the older team lead might still want to be able to see that employee. Those are different types of using indeed that fixed calculation where you know, aside from what's happening in that filter, I still want to see this particular sort of data. So we have a few more minutes. I hope that answers all of your questions so far, especially Bart. Let's see. So Hans is saying you want to filter them out for the older team leads. That might be a very specific question. So Hans, just seeing how. I think that could also be fixed, Hans, more on the data side. So I'm personally always very worried to use all kinds of trickery within Tableau to fix something. You could also say we have our employee data, and they just have another link to who is their manager. And then the newest team lead is allowed to view the data, also the older data. The only thing that would happen is that the older team lead might not be able to see the older data, but you could also say that person is no longer a part of their team, so there's no use there. So I would say you could also try and fix that on the data side instead of trying to, yeah, mangle that in Tableau. But that would be a very specific question, so you could either reach out to our support if you are part of the Information Lab support, or reach out via LinkedIn or something, and we can try and figure something out there because that seems like a very specific question. And we need to know a little bit more of the background of how the data looks like. Um, so I hope I've answered the question about the answered that live. Are there any other questions at the moment with regards to level of detail calculation? Because we have only a few more minutes left. So if there are not, I'm just going to show you very, very quickly then how to use multiple levels of detail in your calculation. What this overview does, as you can look at, is I have the same sales data. I'm plotting it on a continuous month scale. So I have my different years and then my months. And I have a few subcategories, such as bookcases, chairs, and furnishing. And what I'm actually doing in this particular visualization, I'm comparing the highest sales within a subcategory and comparing it to the highest and looking at how far from the highest sales ever within that subcategory are you. Um, but I'll get back to your question in a little bit. Now, what type of calculation would we use? Well, we have that month sales. I'll open it up just to show you what that would look like because we don't have enough time to go into too much detail because I do know there's a question. What we're actually doing there, I'll make that a little bit bigger just to show you that you can use, as you can see here, multiple levels of that detail calculation. So what we are actually doing is for each subcategory, so in this case bookcases, and each month we're calculating the sum of sales. So we know exactly for a whole month how much sales they made. Now that is pretty much what's already happening in our visualization. So we have already our sum of sales for every month. But we're adding another level, which is saying for each subcategory, I actually want to know the maximum of that sales per subcategory per month. And then this one we're doing in also the sum of sales divided by that same amount. So in this case, you're getting a combination of looking at all of these numbers per subcategory, these amounts of sales, comparing it to the highest sales ever for each subcategory. It's a great way of doing a comparison within a data set on multiple levels. We are running out of time, so I'm just going to check Bart's question. It's not a clear picture. Let me see if it's not giving you a very clear picture. Um, Great blog, in my opinion, is this is a very basic but very great blog. If it doesn't give you an idea of what that means or the picture isn't clear enough, this could be a good blog to read up on and find out that order of operations. Yeah, I think, Bart, that's basically what you could do. So one of the things is indeed y- not so necessarily you want to get data away from users. It's more saying this is I want to compare to a higher level, or I would definitely want you to take this lower level into account aside from what's happening. Or as you can see in this last example, we're comparing the sales. Yeah, I'll definitely show you once more what that looks like. It is a pretty long one because there's a lot happening. And what I'll actually do is we have that fixed where we do that one, and then there's another, and I'll actually do this. This gives you maybe a little bit of a better idea of what's happening, and I'll make it slightly bigger. So we have two levels of fixed. One is on the subcategory level, and the other is at the subcategory and month level. Um, so what we're doing is we're not taking away data here, Bart, for instance. We're not allowing our users to filter. We're just saying we definitely want this to happen on this level. But if we use normal Tableau tooling, so only whatever is in our visualization, we couldn't do this comparison. So yeah, that would definitely be the way to do this. So I just want to share one more slide, which is the very, very last one. You can always find our recordings. I'll also post this one in chat. It's a bit.ly link. There you will be able to find all of our uploaded YouTube, so also this webinar and any of our other webinars on other topics where we talked about charts, we talked about the basics of Tableau. So there's many different ways that things that we talked about. So you can find that through using this bit.ly link. Yes, so Gerco, always very important that those uh, curly brackets, definitely every time you open, you always close. My trick sometimes is to start typing like this, so I always know that I have both of those curly brackets already. It's the same as using an if statement with an end statement at the end. I hope you've learned something from today. If you have any other questions, you can find me on either on LinkedIn, for instance, or through the informationlab.nl website where we have our blogs on many different topics. Feel free to reach me again, like I said, on either on LinkedIn. Um, I'm happy to share any knowledge that we have. Yeah, so I hope you learned something today. If the, if the only thing that you learned is curly brackets, that's absolutely fine. And I hope I show you a little bit of a few cool examples of how to use those level of detail calculations. Um, I'll hope to see you in the next year when we do more of these sessions on many different subjects. So goodbye for now and enjoy the holidays.